Hey everyone, it's Don here from the board. Thank you for joining in on another video. Now, I'm going to be continuing on what I started in a previous video, and this is going to be the part 1 of building a 2x2 PCB using KiCAD and the KiCAD tutorial. However, before I get started on that, I thought I would just show something that I got in the mail very quickly, just as like a teaser, which is this. So, big fat heavy box. Look at it. It's the size of my head. This is my grab bag that I got from Signature Plastics as part of the record-breaking 300 grab bags in 80 seconds sale. Arrived in the mail yesterday, so I haven't opened it. As you can see, it's still sealed up. I've just taken the invoice out of it, and I'm looking forward to doing a video or a live stream, something of that nature, to actually crack it open and have a bit of fun. But getting back onto our main content for this particular video. So a couple of days ago I did a part 0 on building a PCB following the guide from what's the name? Rui Ki Mao or something like that. Sorry if I didn't get it right. I do have it loaded on my screen, but obviously I'm just talking into the webcam rather than looking at my screen right now. And in the part 0, I went over basic theory of how a keyboard matrix works, as well as laying out some of the basic tweaks on folders when you unpack the files that you can download from GitHub, and then just how you load that library component file. Now, I stopped before we started laying out the schematics, and that's where we're going to take off from now. So if you are watching this video and you're seeing it because it's the part 1, there is actually a part 0 before this that you can have a look at as well. So let's switch off on that. Let's switch off on that. Let's go over to my monitor. And so here's KiCAD loaded, ready to go. But let's bring up the guide first. So this is the guide that I'm talking about. I will provide the link again in the description, and it is by Rui Ki Mao, the keyboard PCB guide. So last time we did a little bit of setting up, and we got to sort of just around here where we added the actual library parts file. And we'll take it off from here, placing components. Let's flip over to KiCAD. There's the base KiCAD, and once you actually double click on the schematic, you end up with the schematic page. First thing that the guide tells you to do, the first thing that the guide actually refers you to do, is to add your 2x2. So let's go and do a place component. Now you'll see there's shortcuts all the way here if you prefer to remember the shortcuts. It gives you a little pencil, and you just click somewhere on the screen and it will show you exactly what you're wanting to place. Let's look for that Amiga, and we want the 32, what was it? Is it the 32.4? 34.2U? The M? Let's go back to the guide. 32U4, just a straight 32U4 under the keyboard parts, which is this one. There we go, and we're going to hit OK. Gives you your basic layout, and I'm just going to plonk it somewhere in the middle. Now you'll see you can use standard sort of CAD software mouse control. So rolling in and rolling out will obviously zoom, but it will zoom relative to where your cursor is. Now, oops, wrong one. That's the one that I want. You can't really see it very well in this picture, but if you go to this one, and let's resize my window a little bit so we can have a look at the actual pins. You'll notice the guide actually has a slightly different looking controller. Now, I don't know what the deal is with that, in that, is this a different reversion of the controller? Is it just a different graphical representation of it. And my only thoughts and concerns about this, which I haven't actually taken the time to chase up or ask, is if you physically build this PCB and this connection, the actual traces and the routes and stuff like that, and then you buy an Atmega 32U4 to hand solder in because you're prototyping rather than getting a factory to do it, will the pin outs be in the same physical location? So the pin outs have the same numbering, I believe, because you'll see pin out 1 is here, which is the INT6 ANO P6, which is the P6 ANO pin out 1. Pin out 2, the UVCC, is still pin out UVCC. So the actual numerical alignment of these is correct, but the physical placement is different. How much does this matter? I'm not sure. So that's just something to be aware of consciously. At some point, maybe somebody would have to answer that question. If you do know, I would love to have a comment in this video saying yes or no, it's a problem, it's not a problem. So let's expand this back up. So we've gone and dropped down the Atmega, and we want to have a ground crystal as well as a couple of capacitors. Now, just to explain what a decoupling capacitor is, because I went and looked this up, is that it's essentially a kind of surge protection and filter. Essentially, capacitors, they take charge and they discharge charge. Having the decoupling capacitor means any fluctuations in the power that is passing through the actual power source and line is smoothed out. And if there's any brief interruptions, the capacitor can actually hop over that. So if you have, for example, an uninterruptible power supply, sometimes they will have decoupling capacitors in there with a large capacity, so it can actually prevent brownouts and phase drops, because they'll continue to provide a steady stream of power for however long the capacitor has the capability to discharge for, which essentially allows the electronics to keep performing, hopefully until the brownout or the surge has passed through the system. So let's go back to the schematic, and what we want to add is a couple of the we'll have 2 of these small capacitors. So let's add a component, and we go C, small, unpolarized capacitor. Okay, we're just going to pop one of them there, going to pop the second one there, just like that. Now we can move these, obviously. You can press the M with the cursor. You don't actually have to click, but if you do want to use the mouse, you can also right click to bring up your dialog box. But because we're in the pencil mode, if I was to use left click, it wants to add a component. So let's add a ground. And then what was the other component that I'm after? The external ground. Now, does it tell me what the XTA ground? There we go. Alright, so let's pop those components on. So you see laying it out's actually relatively easy, and that's the configuration that we want to have. So making sure that you've got actual cross-point connections, and then you have C1 going to XTAL1, C2 going to XTAL2. Now there is a wire tool that you can place wire, and you can also shortcut this by pressing W, and you click from the connection points and you click to form bends, just like that. Probably should actually move components a little bit so it's a little bit neater. How did they have this? I have a terrible memory. Okay, so straight through. Let's form that junction. Go there. I'll go there. Now, you'll notice how I actually started from here and I didn't just go straight from the capacitor to capacitor. I found through my playing around with that if you do that, it doesn't actually form a junction. Whether the notation is purely for a cosmetic issue or not, it's safer to actually go to the exact junction that you want to form the dot, which indicates that you've got a connecting junction. If you don't, then potentially you might have a problem because the wire tracing isn't going to follow. Now you can actually select stuff in bulk and move it, just like I am now. So I've just dragged and clicked around, and that allows me to move the whole assembly that I've completed. Going back to my wire tool, and then I can go extal to 1, and extal to 2. Now you'll notice that, you know, I haven't lined them up perfectly, but you can actually, in the tool, you can actually click on it, and yeah, you can drag the wiring around. So if it's not super neat when you start off, don't panic, because it is fixable. But you'll notice that my junction's gone funny, so let's see if I can, that's what I want to move, and then I'm going to move the junction. Alright, so it doesn't like that. So let's just, there we go. There's a wire there. I'm just going to delete that. So you can use delete just to also delete bits and pieces, and then going to drag that down. Delete that junction. How about I just delete that wire? It's gone into the wire tool. There's a little bit of fiddling around, isn't there? There we go. Alright. So as you can see, it's a little bit, I wouldn't say clunky, but because of the way that the snap to the grid works, that's just kind of how it is. There you go. Now we have our crystal. Let's go back to the guide. So we've connected the XTAL1, XTAL2. Now you'll notice that they've been relabeled C1 22 pico, C2 22 pico, and we've also relabeled it to the component X1 in that. So zoom back in. You can right click on the component and you can edit the component, and it comes up with your dialog, and up here it gives you the couple of different values and whatnot. So in here, the field value over here, we're just going to turn that into the X1. And then similarly, so for our capacitor, we're going to hit E for the edit, and we're going to call that C1. We move down to this value, and we're going to call it 22p. Hit OK, and there we go. Go over to component 2. If you center it with your cursor, it makes it a little bit easier, because generally, unless if you have a lot of components overlapping, it knows which one you're after. Whereas if you're in junctions, it'll come up with that clarify your selection thing. So there's the C2. Go down here and another 22 pico. There we go. So that's our first component block done. Back to the guide. Ground symbol, it's all connected. Now we want to have a bunch of more decouplers for the voltage power source there. So let's go and put down C3, 4, 5, 6, and 7, as well as a connection to VCC and ground. Let's just, where do they put it overall? Let's have a look. Whoops. This is really weird for me, cycling in between, because, alright, so they just leave it up somewhere random. So let's head up this way, and we'll Shift A to put some components, and we want some more of the C smalls. So there's 3, 4, 5, 6, 7. I don't actually know if there's an alignment tool or anything like that, but with the grid at least you can kind of use it to align up okay. So you can press the M, which allows you to basically just move stuff. Let's move that across so it's consistent. I'm not actually watching my mic levels as I talk, so hopefully I'm not actually being too soft. It's a Saturday and there's actually still quite a lot of traffic going on by. So let's go with a VCC. There's a power VCC, and we're just going to pop that there. And then we also want a ground, so we're just going to go with a ground, which, there we go. Let's zoom in there. At this point, I suppose we should probably just edit them, so we're going to go with C3. So see, it asks for that clarification because it thinks there's multiple things there. C4. C5. Whereas if I'm floating in the middle and I do the edit, it doesn't have anything that it tries to clarify because it knows that I'm only talking about the capacitor. I'm not talking about that connection point. And then C7. Now let's have a look. We want 0.1, 0.1, 0.1, 0.1, and 4.7 micro. So that's where you go with edit. 0.1 U edit 0.1 U edit 4.7 U. Okay. Yep. And then we just hook them all up with the wire tool. So back to my wire tool. Click. Click. Actually, they didn't do it that way, did they? No. They had... Well, it's essentially the same. But if you want it to be neat and pretty, and you want, you know, all your junctions to be clean and visible, then yeah, you essentially will have to make it look neat and presentable like that. But make sure that you have the junctions, because if you don't have the junctions, it may not necessarily work. I'm not 100% sure of that, but it doesn't hurt because it does actually look nicer anyway. Oh, still trying to get used to the scrolling and whatnot that it uses. Alright, so let's have a reset switch. So SW switch, and then a resistor R going to a ground and a VCC next to pins 13. Let's go back over here. Let's find my 13. There's the reset. There. Reset. Ugh. Having a shocker this morning, aren't I? So let's get rid of the wiring tool. Let's get the placement tool. And we want a switch, push switch. We'll have that just line up there. Then we want a resistor. Where'd my resistor go? There we go. Now you'll notice the orientation isn't quite right, but what you can do is you can actually rotate them as well. So you can orientate with rotations, just like that. And then of course you can move them however you need to. So we also have a VCC over here, and we also have a ground over here as well. So VCC straight to resistor, ground switch to push switch, and then a 10K on that. Let's component. I'm going to call that R1, and we're going to have the value of 10K. Now the orientation of the VCC and the ground technically doesn't matter because it's only a schematic. The schematic is there to build the relationships that it needs later on. But if you want it to look sort of neat and like the guide, then you can obviously play around with it to get the alignments like they've got it. And we'll just neaten things up a little bit. Back to the wiring tool to connect all of that. I'm going to go out to connection to the reset and then a switch to that. So that should look pretty close. Yep. Now the other thing that you'll notice is the way that the actual writing is. The R1 is down below and the 10K inside, whereas on the actual guide you'll see the R1's on top and the 10K is, you know, underneath it. I do notice later on that I've had similar weird things with resistors, because you can actually play around with where the lettering goes. There is actual orientation of like text and things like that. The justification of text, which you can see over here, it's a little bit weird. I tried playing around with it, but I couldn't get it to look exactly like the tutorial guide did. At the end of the day, it technically doesn't matter. It's really just for aesthetics and ease of seeing what that component is and the values without having to actually go into the component properties box, which we're currently in. Right, so let's I keep going to the wrong window. Let's move along. So we want another resistor at pin 33 going to ground. Pin 33, where's my pin 33? It's really annoying when they have these jumps, because then you're like, where is it? 35, 6 to 40, 33. Alright, so let's just go pop that out there. And then we'll have a resistor. Stick that. Rotate. Move. Ding. Then we want a ground. Rotate that. We'll just give it a short connection. Okay, and the value for this resistor is also a R2 10K. Let's go back, edit, reference, R2, 10K. Next, let's add a USB port. So we're looking for USB mini micro B. And it's going to be living up around here, I think, from memory, because of it wanting to be near some of these D+ components. USB. Let's open up keyboard parts. There we go. There's the mini micro B. And let's drop it around there. And we want one VCC, 2 resistors, a ground, and a capacitor. Let's try and remember that. So we need a VCC, we need a ground, we need a capacitor, and we need 2 resistors, don't we? So we can just dump them all there. 2 resistors, a ground, VCC, and a capacitor. So let's move everything into alignment. So D- and D+ have my resistors in line. Let's move that over here. Rotate. Let's rotate that. And let's move that. Now you'll see how the letters are actually overlapping, the values are overlapping. That's what I'm talking about. For some reason, when I tried to play with the alignment, I couldn't get it to exactly move around, but that's okay. So I think that's now R3. Let me just check again. R3, R4, and 22 ohm, not 22 kilo ohms. So it's very important to get your units of measurement correct as well. So that's going to be 22, and then it's going to be R4 and value of 22 as well. So you'll see the overlap. It's not particularly pretty. Not quite sure what the best way of doing those alignments are, but you can obviously play around with that as you need to. Cancel that. Wire tool, hook that up. Wire tool, hook that up. Next thing that we need to add in, VCC on the VUSB into port 1, and then we'll go straight into the UVCC. So let's move that. Let's wiring tool. How did they have it again? Straight across. And we're going to go like that. Those can be moved later. I realize I'm not the neatest of builders here at the moment. So let's turn around the ground and the capacitor. Let's rotate that. Just rotate that. We'll move that over here, and we'll move that over here somewhere too, roughly. And the edit is going to be, what's my reference? C8, is it? C8 and 1 micro. So there's C8 and 1U. And our wiring is going to be from U ground straight across the ground, U cap to the capacitor. They have a connection bridge, and then the ground and shield, which means these guys will have connections down here. Let's move them down here. Oh, you'll notice how they've got a strange a flipped around orientation here as well. So you do need to make sure that the wiring does go to the right places. So U cap, and you'll see that I'm actually going to bridge straight across without it's going to go ground, it's going to go shield, and it's going to look like that. So it does actually match what we've got the connections to, but because the pin arrangements are slightly different on this Atmega, the actual wiring looks different as well. Okay, so D minus and D plus. Let's go D plus there, and then D minus is going to go there. We've got ID, which is left blank, and I think that's the USB hooked up. Okay, so a little bit messy, but it's okay for the moment. Next component that we're going to play with, so we've connected all of that. Got that capacitor, got the USB, and let's see, let's connect all the VCC's connection together and all the ground connections together. You would place a capacitor between a VCC, but we don't care for that on a keyboard. So, right, so what they're talking about here is, you'll notice on everything on the actual controller that has a VCC or ground, they've now added a VCC and a ground connection to that as well. So, and that way it allows you to have connections that go to the ground plane later when you actually put in a PCB layers. So VBus, anything that's got a V on it goes to VCC because that's essentially the voltage, and anything that's got ground will go to the ground plane. So let's follow suit, shall we? There's VCC, so it should go to a VCC, but I don't know if you're allowed to just hook it straight into a connecting one. Can you piggyback it, or is it safer not to? Let's make it safer not to. So going back to placing components, we'll just add a VCC, one for there, and what am I doing? I'll put that there. About wiring tool. Obviously, you can make things a lot neater than I have. If you've got the time and inclination to do so. I'm just doing this as a hodgepodge so you can really see how easy or hard, or the things that you need to be aware of when you're actually trying to use KiCAD. This is only like the third time I've been playing with it, and it's actually a good way of showing you what's going on because I don't have a lot of innate experience. What I mean by that is I'm not doing anything that's particularly fast or tricky because I haven't been using this for very long. So the speed that you're moving at is going to be potentially similar or faster. Yeah, it could be potentially a little bit slower, but it all depends, of course, on how you work. Now, I realize that that looks super messy, but there's probably a good chance that you could connect all of that block into one VCC. However, because I actually don't know, I'm just playing it safe and having them all separate compared to having them with a one connection. And similarly, so that's actually taking care of all of my voltages now. The V-bus is there as well. And then I can have a ground component. So let's go and add a bunch of grounds. Now, similarly, the ground is probably fine to be able to have as a connected. 2, 3, 4. Someone can confirm that for me if they wanted to. Easily enough, I suppose. And then you can always go back if necessary and clean up your schematic, because it is only a schematic, and it's like I said, it's all about building the relationships between the components, because the actual physical layout comes in a separate step. That's when your placement does actually matter a lot more. Okay, so we've got all of our ACCs, VCCs, UCCs connected, and then we've got grounds also connected. And it's time to build our switch matrix. So I kind of drew this out before, but let's go over matrix theory again, in that you have a switch which breaks the contact. You've got diodes which restrict the flow of current in one direction, so it can't go back in the opposite direction. And by having columns and rows that you'll see that we add on later, you can actually scan across your controller, which will give you signals on the different pins, and the controller will then go to the software and say, I've got a signal at this pin and this pin, what should I output? And that's how your keyboard matrix works. So key SW and D are what we're looking for. Let's move over a bit and let's go up, place components, and key switch. 1, 2, 3, and 4. Now I think that one's out of alignment. There we go. Now we want diodes. And let's rotate that around. So for every switch, you're going to need one diode. Alright, and how are we labeling them? I believe we're labeling them to match the actual key numbering as well. So you'll see key 1, diode 1, key 2, diode 2, key 3, diode 3, key 4, diode 4. And they go diode to diode, diode to diode, and then the plane from there to there. I don't even know what I should be calling it, but that's alright. So let's edit, and we're going to call it key 1. Key 2. Hey, that works too. Key 3. That certainly would speed things up, wouldn't it? Still need a whole bunch of clicks though. And key 4. And of course to match. Oops. D1. D2. Maybe this is where we actually play with the justification and sizing, huh? Learning things live. It's awesome. D4. Now we get our wiring tool, press W, diode, switch. Oh, I haven't left a lot of spacing here, but we can fix that up. So let's drag those and give ourselves a bit of spacing. I think there we go. Diode to diode. Goes across like that, and like that. And then from here, just hop out one branch to make it visible. There we go. And I think that should look like what we have here. Let me put that side by side. Diode, diode, down, diode, diode, down, and then outside. Looks good. Okay. Now we add our rows. You basically connect them with labels. How do we do labels again? You can place label, Shift L. So you can go from, you can go there. We're going to call that col 0. And col 1. And then we have row 0 and row 1. Just like that. Then we use our wiring tool. We say we want the wire to go to that connection there. That wasn't very neat, very clean, was it? Let's go fix that up. There we go. Undo. Let's move it. There we go. And then there we go. Try and get that on the same grid line. There's our columns. Let's just move that across. And then there's our rows. Where am I going? There we go. As you can tell how much fun I'm having with this. Now, at the same time, we need to add some pin assignments because this is a relationship reference point, and they're adding it to 41, 40, 38, and 39. Let's see, rows on 40s, which is all the way down here. So we'll go Shift L back to our label tool, and we'll put row 0 there, row 1 there, and then col 0 and col 1. And with our wiring tool, we'll bridge those relationships. And what that means is you don't have to draw wires directly to those pins. Now, if you really wanted to, you could actually go from here and route a wire to those pins, but it would look a lot messier. But having this actual assignment means you don't need to, because it will know that that's what those pins are going to. Okay, so there's the schematic. Actually, I think I was meant to label the controller U1, wasn't I? Did I do that? I probably didn't. No, I didn't. So there's the U reference. Let's go and edit that. And it is U1. And there you go. So that took about 40 minutes of me dicking around a little bit to draw our basic 2x2 schematic. Obviously, it's a bit faster if you're going to be doing it by yourself, because there was a couple of minutes at the front where I was talking about my grab bag, and then there was a couple of minutes of me adding extra VCCs, digging around for components, talking about, you know, decoupling capacitors and just general fumbling. The more that you play with the schematic editor, the faster you're going to be, the more familiar you're going to be, you know, knowing your shortcuts, using your keyboard shortcuts rather than right clicking with the mouse, and so on and so forth. And yeah, you'll be able to knock out some awesome schematics very quickly. Now, of course, the bigger your matrix is, the longer it's going to take. But what you can actually do is you can copy entire sections. So for example, I've highlighted those 4, and you can actually copy them. You can copy the block, and bam, there you go. There's another lot, and then all you have to do is actually hook it up. So before you do the reference connections, if you set up a particular grid, even without the wiring, for example, then you can just quickly copy entire chunks or portions, and then away you go. And of course, you can also, I didn't want to cancel, you can delete entire blocks as well. So there it goes. Alright, so I'm going to end this part here. Good timing with the baby just crying in the background. And then the next part we'll move on to actually doing the component associations and putting down the footprints. So I hope that was a little bit enlightening and shows you the actual processes that you need to go through in regards to setting up and putting a schematic together for building your own PCB. And yeah, it's very, very easy. There's no actual difficult parts around it. It's just a little bit time consuming when you get started and knowing what you're supposed to connect and how the actual tooltips work, because you'll see as I change between tooltips, it doesn't actually tell you what tooltip you've got. It doesn't use a different icon. That's, you know, obviously something that would be nice if they could differentiate that so you know which tool you're using. But hey, it's open source software, and I think they've done a really fantastic job with it regardless. Yeah, so I'll do another video continuing on with the footprints and components, and then that way, you know, you can refer to that video separately without having to skip or jump through all of the stuff before. And yeah, I'll get on to doing something with my my grab bag box over here at some point as well. So thank you very much for tuning in. Make sure you check out all of our podcast content as well. If you haven't, you can find us on www.theboardpodcast.com. So until next time, as usual, happy and clacking.